let's continue with our class. I haven't seen much activity from you guys on any of the forums and lists, so I changed a little bit the grading scheme. So I think that will be in your favor. So the kind of extra activities are just pure bonus points now. But instead I added one project. Basically what you're doing now in the lab will culminate in the beginning of next week in a mini project presentation. So basically the first things you're doing, you're kind of trying to get lots of devices talking with each other. That will be project 1, which will count for 10% of the final grade. So you basically can earn that pretty soon. So that's the only slight change I will make, and I think it will give you in the end more points than if I would look at your online activity. So I hope it's in your interest. Yeah, hope you're all awake because you basically have to start working now. And we want to learn how to speak Internet of Things today. So basically we need kind of some protocols. And if you remember, in the very beginning of the first class, I was already asking you once about protocols. Doesn't matter if you haven't found so many there, you can actually pick some of the ones down there, or formats, markup languages. So basically the way you can communicate in the network between machines. So I want you to do a little bit of research about these different protocols, and you can use more than we have there. So basically, kind of, you know the spiel already, so a little bit of 10-minute research, ask Google or any of the search engines you want. And what I want you to actually research is examples and properties regarding speed, readability, and user friendliness. Yeah? In terms of how easy it is to program, how easy it is to debug, how easy it is to work with it, how easy it is to get started. So basically really focus on examples, how the languages look and how the way the communication looks and how reliable it is, how speedful it is, and what kind of problems and benefits are in there. So basically I want you to work in small groups, ad hoc groups here with 3 to 5 persons. And of course what you do now has to go in our little lecture log in the end. And everybody of you, so divide and conquer, kind of in the group, discuss quickly who does what. And then each of the group members does 2 protocols, and you can have one protocol several times, yeah? Basically 5 minutes per protocol. So, and then for discussion purposes, pick 2 advantages and 2 disadvantages of the respective protocol you have, and then you present it inside your group in the second session and try to sell it. Good, then let's go. 10 minutes. Is the task clear? Yeah, just discuss with yourselves. Just think about a minute which of the protocols you want to use, or if you know something more, then take more. I would actually suggest that you do CPR and JSON in the same group, because you will see why. Okay, let's switch to open discussion. I have prepared something to have as a back for discussion. So did anybody study something else than the ones I gave you? Did somebody come up with a different encoding format, which is in the Internet of Things? Yeah?
Yeah, for instance, the MQTT, message queue, telemetry export.
We will actually, you are ahead of your time, because there will be an exercise on MQTT just in a bit. Is there anything specific regarding encoding with MQTT? Yeah, so basically in how the communication between machines is actually working, because I think it's actually protocol agnostic. So that means the encoding is not really given by MQTT. So you can use any of these on top of MQTT. Okay, great. but you will be able to use what you've done there in a second, don't worry. So, what are the favorites? Now, to do a hand count. Who prefers plain unstructured text? Nobody. Who likes to communicate in binary? So let's kind of say in CBOR. Who thinks CBOR is the best? Nobody. XML. Who's an XML fan? YAML. YAML is kind of as nice as JSON. So you all want to do the JSON, yeah? Just for a check? All JSON. Okay, good. So what's the advantage of just using plain unstructured text? Readability, okay, you have readability too with JSON and kind of a little bit with XML, but also with maybe in kind of ranking in terms of readability, I would say it's probably YAML, JSON, and XML. Because I actually think that yet another markup language is more readable than JSON. Okay. So what about kind of the ease of use with just plain unstructured text? So if you kind of
you don't have to learn a new protocol. It's like just writing the text with JSON, XML, or YAML. You have to learn the structure.
Yeah. So if you want to send something just as a simple text, you just need a binary to string converter or something. So to basically kind of represent an integer as actually some numbers. So that might be actually for pragmatism the easiest approach. Yeah, so to keep that in mind. But JSON is great, but you kind of get in the big library to actually work with JSON. It might be because of the tree structure from JSON or YAML, because they are just very similar. It's hard. It might actually be more pragmatic to use text for communication. So what about binary? Generic. What about a generic binary format? What are the disadvantages of it?
It's very hard to read.
It's very hard to read, and not only by humans, but also by machines. So if you haven't really specified how the communication goes, it might actually be that nobody can actually read your binary format. What is the advantage? It is heavily compressing the communication, yes. What other advantages are there? We had actually, yeah?
You can actually like send whole objects when you send binary files.
What means whole objects? Are some kind of internal serialization format or so of the machine, or?
No, for example, if you have a Java class,
Yeah.
if you have a Java object, you
Yeah.
can send that object, and it's being sent in binary.
And you cannot do that in XML?
Yeah, you can, but in XML you can read it, and if you send it in binary, you can't actually read it.
Yeah, so,
It's
yeah.
easier.
But basically kind of being able to send methods or so, which is kind of the typical object orientation. I think the only one which directly offers this are specific XML dialect and yes, specific binary serializations, that's true. Yeah, that's something you should keep in mind if you need to be able to send kind of runtime objects and executionable code or so over the network. Then you want to do binaries. When else do I want to do binaries? We talked a little bit about obfuscating in one group before, but so think about something where kind of the obfuscation is actually standardized. How is that? What is that? If you send binary, it's called encryption, yeah? So if maybe we want to send something encrypted, then it might actually make sense to send it in binary. But okay, you don't have to. So how would you send something encrypted just as text? What would you do? No, just as, so if you don't have binary, so if you can only send text, what is usually done if you send some kind of encrypted code? You encode it as base 64, and you know what base 64 is? Yeah. Basically a text format where we only use the displayable characters too. So we only use, I think, only 6 bits of 8 bits, which we can possibly send there. So yeah, again, we're blowing it up. So that there's kind of a trade-off always. Binary is much more compact usually than text. When do I want to do, so think of an application. When do I want to use binary communication between machines versus text? And versus text means now all of the text-based. So if you design an Internet of Things system, yeah.
Yes, where the speed matters.
Where the speed matters, and when does the speed matter? What does it mean?
Real-time applications.
No, it basically means that something produces a lot of data. Yeah, so if we have somewhere a lot of data, we want to probably consider sending things via binary. About what if latency, if not kind of amount of data, what if latency matters? Which format would you take then? You know what latency is, yeah? The response time. Is there any advantage of using binary versus text? Usually not. Yeah, so for latency, especially if you send small data packages, it doesn't matter. So if you send a lot, then there could be something in terms of compression. Also, actually, real compression might be a reason you want to send binary format. Yeah. So, what is so with some groups I discussed it already. What is the big advantage of XML versus all the other text-based languages, text-based exchange formats we have here? Why would you choose XML?
It has a predefined structure and a schema.
It has a schema, yeah. So schema. So what does that mean? What can you do in the schema? Why is that an advantage and a disadvantage?
Because you kind of know what the following document will look like.
You know how it looks like, and so yeah, think in programming language. What is the great thing what a schema can do?
Can validate.
It can give me types. It can describe types. It can describe how specific, how the structure looks. It can actually define object structure. Yes, it's not something you agree as a human on. It's something also a machine can understand. So if you say, okay, this is a temperature humidity sensor, it always gives me temperature and humidity, and both of them are float values, then this you can actually write into a schema. And there you see the disadvantage too. Why is that also a disadvantage?
Additional overhead.
That's true, but something else, something more pragmatic.
I mean, probably the data doesn't match the schema.
Yes, so the problem is if if your system can only work with temperature and it gets a temperature humidity tuple, then it might not be able to understand it. If you have some kind of JSON thing, you might just parse if there's something called temperature, and so use the semantics of the name, and then you read out that value and you're fine. Or if the schema defines the temperature must be an integer value, but your logic can actually also read floats or vice versa, or so then this doesn't really matter. Yeah, so you might lock yourself down, and that is kind of this thing that this is the main reason why XML failed in big machine-to-machine communications, is actually that the schema was good for debugging and defining things, but it was really hard to make heterogeneous systems work with each other. So if you have the Internet of Things, which is all about integrating very, very different technologies into one and building systems, then this precision here of narrowing down is actually hurtful for building bigger systems. Yeah, so keep this system element in the back of your mind. We're talking about Internet of Things, and we want to kind of integrate a lot of things into one. That's why we want to kind of have a nice trade-off between simplicity and complexity.
But is a XML schema mandatory?
No, of course you can just ignore it and use XML just like JSON or so then it just has, because of the tags, a little bit of overhead. That's true. So what is then? So if you look at XML without a schema, JSON and YAML, what are the advantages and disadvantages for these three in comparison with each other?
Yeah, in this case, YAML has the least amount of overhead, I think. And since all of the three need some kind of parser, it's just the better solution in my opinion.
What could you make an argument for JSON still? So I agree with you. YAML gets more and more popular lately. Have you read that actually YAML is valid JSON? Yeah? So actually YAML is kind of a different way to write down JSON. So most JSON parsers can actually understand YAML. But okay, so classic from these two examples you see here. Why would people prefer still JSON over YAML? This is the million fly argument. Because more people, okay.
When you have text file, you still will see the structure if it's just one line because of the brackets. Then YAML, if it's just plain text, you don't see any structure at all.
True, so especially if you have trouble with returns and line feeds, then that JSON would be preferred. No, but the argument I wanted to, yeah?
Because they already know JSON and would have to replace it.
And actually more people are using JSON. So it's just, if you want to be mainstream, you probably will use JSON. And YAML is kind of, if you need to work on debugging, yeah, so you might prefer actually YAML. Yeah, so if you want to be faster in actually reading the stuff. So this is all the trade-offs we want to do. We could kind of look at, debuggability, readability, speed, latency, and and also convenience and actually the task where we wanna use it. So that you have to factor in. So all of these we actually use. And lately, so guess what is the most used one in the Internet of Things? So there's a lot of JSON, but what is then just right after JSON? No, it's just pure unstructured text. Yeah? So simplicity is often very important because be honest, if you would program what you are sending around now, it's just on and off, isn't it? You don't encode on and off in status on or off. And what you have done is just sending on and off, which is basically just sending around text. So don't ignore that. So text can be actually the best option for your project. So now we go to the big guys. Of course, we are doing our own stuff, and the nice thing in the Internet of Things is it's not only for the big companies. There is kind of this do-it-yourself and small companies and entrepreneurial effect to it. But of course, we want to know what the big guys are doing, yeah? And the problem is also the big guys have actually figured out that you can't work alone. Yeah, you have to somehow work with others, and so the solution for kind of the small guys or people like us usually would be we make an open source project and we make some kind of community. Yeah? What big guys do is we make a consortium or an alliance or something like that. Yeah, so as you probably suspect, my class is a bit more about what we can do and not so much what the big guys are doing. But I want you to at least kind of be aware what is actually happening in the industrial sector. And this is what this mini exercise here is about. So there are tons of consortiums. Yeah, if you Google for Internet of Things and consortium or Internet of Things alliances, and especially could look like a ranking, you will find hundreds. And this is fine. Just pick some, but I definitely want you to take a look at some pre-selected I have picked, which is the OCF. You will figure out what this acronym actually means. The All Seen Alliance, the LoRa Alliance, and look at the activities around Eclipse. It's kind of a nice bridge activity between the open source and industrial sector. Yeah, so Internet of Things, eclipse.org. It's kind of a great name, but see what is actually there. So what I want you to do is, genau, 10 minutes. I want you to pick a couple of consortiums or foundations or alliances. Look at the name and what does the name stand for? Who is part of this? Yeah, which companies are actually part of these alliances? Why was this alliance founded? Yeah, why? In how far does it have to do with the Internet of Things? What in the Internet of Things it wants to coordinate or make better? And how much is it to be part of it? Yeah, how expensive is it? Because you will kind of see interesting prices to be part of the foundation or alliance body. Good, so in your team, I would actually say spend maybe 2 minutes to extend this list to maybe 8 foundations and then distribute it over your team who does actually what. Yeah, so spend 2 minutes and actually find more consortiums than this and then distribute the work in your small class research team. I think I can actually give you 15 minutes. It's actually a bigger task. Let's say 15. Good, so we will switch to open discussion now. And as a courtesy to your peers here, because not everybody has done the same, I would like you to make some topics in the Moodle forum with the different alliances, and then you post your findings to there. So we have all the results from the class here also there. Yeah. So in addition to putting what you just have written into the lecture notes, I also want you to publish it on the Moodle forum so that everybody can read about the other things. Good, let's start kind of, what else did you take? I heard some people talking about OSI and Oasis and OMG, so what are the others which we have actually looked at?
OMA.
OMA?
Yes.
What is that?
Open Mobile Alliance.
Ah, yes. Mm-hmm.
IETF, the Internet Engineering Task Force.
Well, IETF, it's kind of one of the kind of old guys, yeah, and
IIC Industrial Internet Consortium.
okay, anything else?
W3C.
Oh yeah, that's an important one, yeah.
The text encoding in CET consortium
Uh-huh,
is from ESA.
cool. Yeah, I would like to hear something about that. Uh-huh, what else?
1M2M.
Mm-hmm, yeah, 1M2M is a ISO, yeah. Okay, let's start with, so have you found something about the OCF all seen merger? Yeah?
2016
When did it happen?
2016.
Okay, and it's finalized or just an idea?
No, I think it's fine. Because the old
Why do they have still 2 portals? Each of them. Okay.
the old scene web page doesn't work with me, so
I did this morning. Maybe just Google for All Scene Alliance or so. Okay, good. So let's talk about OCF and All Scene. What have you found? What is OCF? What did or does OCF stand for?
Open Connectivity Foundation.
Open Connectivity Foundation. And who is in there?
Microsoft, Samsung, Qualcomm,
Mm-hmm.
necessary producers of chips, Intel, and
What about Amazon and Google?
Amazon. I didn't match that, but Google, I think maybe.
Okay, who started with all seen? So who found things about all seen? Who is why is it called all seen? Has anybody figured that out? What is the framework all seen, the all seen alliance propagates? What do they want?
All join.
All join, yeah. So, and I think it has something. The name all seen has something to do with this all join. Have anybody stumbled about IoTivity in the context of all seen? Because IoTivity was also one of the frameworks which has been joined with all join. And I think maybe the specifications from. So, did anybody found with OCF some kind of frameworks which are associated with OCF? OCF guys? Any software? Because I think that was the issue. I think that might be why. So the basic kind of the same companies. So okay, companies in all scene. Has anybody found the list? Nobody can access the website? As far as I recall, it's a very similar set of companies which are in the All Scene Alliance. And All Scene Alliance is a little bit stronger influenced by Microsoft, if I recall that correctly, because also All Join is one of the frameworks pushed by Microsoft, and it runs on the IoT Core platform from Microsoft. So I think the only, so if you want to really, if we wanted to deploy something with All Join, we would have to install Microsoft on the Raspberry Pi, and then there are a couple of examples to actually make that run. But it's not that easy. But if you want to go that way and try out All Join using Raspberry Pi and then set up a system there, and I think there are a couple. Yeah?
You find All Join and the activity on the OCF website now? So
Yeah.
I guess it's
I think IoT activity is now All Join.
okay, they're on different tabs here.
Okay. I think there were both of the frameworks they were working on, and but tell me different. But I think it's becoming the same thing.
They said that they want to continue with IoTivity and All Join, so they don't want to merge it. But
Okay.
it's just a statement from 2016, so 2 years ago.
Okay. Let's move on. So how expensive is OCF? Have you seen or all seen? Any prices? If I want to join.
As Diamond member, you have to pay $350,000 yearly.
Oh, that's not so much. Is there any kind of lower tier?
Yeah, there's Platinum member, that's 5K to 50K, and also Gold member for 2K. And there's,
free.
yeah, there's also basic
Free.
member option for free.
Okay, so actually we could join that. That's kind of quite open. So the LoRa Alliance. Who has done the LoRa Alliance? Yeah? That's kind of a new thing in the mix, actually. So what did you find out? What is LoRa standing for?
I did not find out.
It's called, okay, I tell you, it's long range. And if you have read the syllabus, you see that we will do LoRa in this class. Yeah, so it's kind of a long-range wireless, and it's kind of propagated as the technology to support the Internet of Things, even more important than Wi-Fi. But okay, so the LoRa Alliance, who is in there?
Google Cloud,
Google, okay.
Cisco, IBM.
Mm-hmm.
All three are sponsor.
Who?
And all three are sponsor members.
Mm-hmm.
So that's the top level membership. And I also found ARM,
Mm-hmm.
but they are not a sponsor, they are contributor.
Mm-hmm. So what's their mission? You don't know.
The interoperability and standardization of low power wide area networks.
Yeah, so I think that's a little bit more hardware focused than the other guys, but I think that's pretty important. And So you guys haven't found much about LoRa, yeah? So we will have that later in class. So LoRa is a cool kind of open technology to use a low frequency band to send messages over an incredible distance. So if you can actually get for less than $50 your own LoRa equipment, and then send, if you have line of sight, things over 12 kilometers with a very low baud rate.
Is that the LoRa one?
Yes. And the nice thing is it also doesn't need much power. So with Wi-Fi you might drain a classic battery in a day, and the same you would drain in half a year or so if you use LoRa. IoT Eclipse. Also, no, is there any fees connected with LoRa?
So there is a there are 4 ways to enter and become a member. For institutional members, it's free.
So we as a university could actually join, yeah?
For academic and non-profit organizations. Then there is a adopter, which is basically like institutional, only not for non-academic and profit organizations. That's $3,000.
3,000.
Yeah.
That's fair. So if you make your own company, you can actually be part of that for 3,000. It's interesting. I work with a company in Brazil who just entered the LoRa market and does all their home automation business with LoRa, and they basically cover all the cities because it's really easy. You just need a couple of base stations, and then you can build up your own city network with LoRa. And I think they told me they are part of this alliance. But I see now that they didn't have to pay too much. Even if you're a small company, you will be able to afford that. And
so then there's the contributor for companies which want to take an active role in the LoRa one. That's $20,000, and then the sponsor, which is $50,000.
Great. Let's move on. Very quick. IoT Eclipse. Who's in there?
It is a non-profit and independent organization. The members are Bosch, Huawei, Ubuntu, IBM, Intel, Nokia, OpenHAB, Orange, SAP, Siemens. The purpose is the Eclipse IoT working group is an industry collaboration of companies who invest and promote an open source community for IoT. Cool. And the membership stages are for the whole Eclipse Foundation, 5 stages. The strategic member is 0.2% of the corporate revenue in minimum 25K and in maximum 500K.
Okay.
And there's a committer stage, it's the entry level stage, it's for free.
Interesting. Anything else you found? No, it's fine. Let's move on.
There are many working groups they have, so it's not just IoT, it's like the Eclipse.
But they're becoming really big, so that has changed kind of a little bit since the last time I have looked.
Eclipse is just one part of Eclipse.
Yeah. No, I think that they've finally got their stuff together and actually have some framework which you could. I don't know if you read about Cura in there. So they have their own Internet of Things framework, which is actually used quite a bit. So. And if we have some time, we might actually take a look at Cura. Cura is very similar to Node-RED, so I think we will focus more on Node-RED. But we should keep in mind that there is another thing. So it's a philosophy or taste question, which of the two you are actually using. Okay, so the others. So you had some, let's start down here. What was your extra?
An extra additional?
No, some of you actually picked some extras.
I picked IIC, Industrial Internet Consortium. What I found out, the purpose is coordinate and establish the priorities and enabling technologies of the industrial internet to accelerate market adoption and drive down barriers to entry. So basically make IoT big.
Who's in there? Who is driving it?
Yeah, IBM, Dell, Huawei, Bosch.
It's always the same, yeah.
And they have a whole range of different memberships,
Mm-hmm.
going from a foundation member with
and also academia and non-profit members have to pay 2.38k.
Okay. Guess we're not joining them today. Okay. You had something up there too, or?
Yes, the TEI, the text encoding.
Yeah, I wanted to hear about that one.
It's a standard for representing text in digital form.
Mm-hmm.
And
Who's driving it? Who are the players?
it's a non-profit.
Oh, it's an open foundation. Okay.
The different membership levels. You can join as an individual or $50.
Doesn't sound so open to me anymore.
Yeah.
And they're setting standard. What's their mission again?
Develop and maintain a set of high-quality guidelines for the encoding of humanities text and support their use by a wide community of
Okay. So it's also about archival and actually kind of real text, not only for machine-to-machine communication. Yeah. Okay. What? I think we had 2 or 3 more.
I had the IETF,
Mm-hmm.
Internet Engineering Task Force, which is an open standards organization
Mm-hmm.
working mostly on the Internet Protocol suite for TCP and IP.
Mm-hmm.
It has no formal membership or membership requirements, so all participants and managers are volunteers.
Cool.
Fully grants usually funded by employers and sponsors. So it said officially there is no membership or no membership fee, so it's free for everyone.
Interesting model.
So you have a chairperson, but they have no members or something on the website. And their purpose is just to create voluntary standards to maintain and improve the usability and interoperability of the internet.
Cool. One more.
I had the ICO.
Mm-hmm. ISO or.
It's the International Organization for Standardization, and there is a section for Internet of Things and related technologies.
I think they have a very interesting membership model, don't they?
I don't know, but there are national member
Yeah.
organizations in each country. To be part of that, you have to get in contact with them, and
Yeah, I think you have to be a country actually to join the ISO. Yeah.
I mean it's separated in countries, but you can become a member of the Austrian Standards International, which is the Austrian member.
Okay. Yeah. And what is their Internet of Things mission? Did you find something?
The purpose is mainly to create standards for IoT topics, so something like Internet of Things use cases or sensor network architectures.
Did you find examples?
I mean, there
Or
are
a link to examples? Is it easy to navigate?
a whole list of
Okay. Good. So that might be something we want to revisit. So please share that in several ways. Before we look at basically systems or protocols of how to communicate, because I pushed some people already in the direction of MQTT, I might have to explain you very quickly a design pattern. You have done some design patterns already?
Yeah.
Do you know what publish subscribe is? Have any examples? Where have you used publish subscribe before? You have done Android, yeah? So any GUI thing in Android is usually publish subscribe. Do you know another name of it? How is publish subscribe also called? Observer pattern. Yes, very good. Great. It's written there. So when and why do you want that?
Maybe there's one source which produces some kind of data, and there are many listeners who want to be informed.
Yeah, you have kind of producer, consumer, message passing. These are all things where you actually want that. In non-computer science settings, I always give the Twitter example. Yes, you have different channels, and people can register to a channel. And then if somebody posts something to a channel, everybody gets the message, yeah? Or you can also use WhatsApp groups or something like that. So that's the idea of how it works. So you have and very important, you usually have some kind of central unit in there, yeah? So where you can register and where you can receive stuff. So here's this temperature example where you have basically different subscribers. So you talk about publishers and subscribers. So publishers are the ones which produce the data. So we have up here client C and client B are subscribing to a broker to a temperature channel or temperature topic. And then when client A publishes the temperature data, both of the clients who have registered for the temperature are informed. Yeah? So that's, keep in mind that is publish subscribe, because one of the things you should look now at uses that. We want to look at protocols or ways of actually how to really carry out communication in the Internet of Things. So at least look now at CoAP and MQTT. I assume that everybody of you knows the HTTP post mechanism because you have already used that. Keep that as a comparison in mind, yeah? So what's different to that when you look at CoAP and MQTT? If you find something else, let me know and maybe look at that too, but mainly I want you to look at CoAP and MQTT. We don't have so much time left, so you just have 5 minutes to find an example, find the purpose, and look how well the software support is for it. Example for MQTT. Where is MQTT used? You found any examples?
IoT.
Yeah, okay, that's pretty generic, and that's the reason why we have it. So have you seen any kind of systems where they have used it, or software which is only...
Like temperature sensors?
In which context? So which company uses temperature sensors which do use MQTT?
I don't know companies, but in Wikipedia it says that temperature sensors communicate via MQTT.
Okay, we will do that, yeah.
It's extremely lightweight, so it's suited for a range of home automation systems and where different small devices are used.
Who invented it? Yeah, in which context? Who was the big driver of MQTT? Which company?
IBM.
IBM, yes. Did you figure out what it stands for?
Yeah. Message queuing telemetry transport.
Yes. Why was it built? What challenge was it set out to solve?
Designed as an extremely lightweight publish subscribe messaging transport.
Yeah, but it was actually designed as a machine-to-machine communication protocol. Yeah. And kind of for a lot of network problems which needed publish subscribe. How's the software support? Have you found some libraries? Does it seem difficult to use MQTT? No, there's tons of stuff out there for any type of device possible using. Is it bound just to TCP, or can you, in theory, also use it on other? Yeah, usually it's on top of TCP/IP, but there are some implementations which work on UDP or just really on serial lines. Good. So CoAP. Examples. Who uses CoAP?
Sensors.
Yeah, it's for sensors. Big.
Yeah, all low power, low memory devices.
What is the advantage in comparison to MQTT?
You've got a REST model like in HTTP.
And what is the underlying network technology?
UDP.
It's UDP. But it's kind of very similar to REST. Yeah. So, but again, examples of companies using it. Where can you buy CoAP here in Linz? IKEA. Yeah, all the home automation from IKEA is actually using the CoAP protocol. Good. And we have a little bit talked about that. I will skip that. So I have to explain you what you have to do in the lab today. So you have to try out co-op in MQTT. And so there's a very simple co-op library for Arduino. You have to find that and install it. And then you have to modify it a little bit to run the example on the ESP8266, which will, as usual, control the LED. So you have to learn how to switch on and off the LED. Problem is that the old, really nice extension for debugging co-op was running on Firefox, and Firefox changed their plugin model, and so basically made it impossible to run the plugin on there. So you have to install the Chrome plugin to actually browse co-op messages and then communicate with this device. It's a little finicky, but I can help you if you get stuck there. So for browsing MQTT in an easy way, you can install MQTTFX, which is a small Java program that's much easier to set up. Practice a little bit sending MQTT messages around. And there is an MQTT server running on the Pi, which is installed with Ulno IoT. So you can just use the MQTT server there. So just log into the network, and then you should be able to use MQTT right away. So there's one thing I want you to start and doing, which we will use again and again in this class. I will want you to build an MQTT simulator. So basically, there's some hardware devices we don't have, and then you can just pretend that you have the device and write a mock-up for that device. So you can do that in any language. If you like Python, I encourage you to look at my library. There is a library called Integrate for Python in Ulno IoT, which makes it really easy to write kind of MQTT mockups, both sensors and actors. But if you want to kind of go through, if you're a Java person or you want to write something on Android, please do that. So it could be fun also to just, so in some other classes, I, for example, make the GPS available via MQTT from your Android phone, or the gyroscope available from your Android phone on MQTT. So that's kind of something which you could probably reuse if you do that now, or just build actually, no, forget it. Just build what I ask you to build here. We do that other stuff later. So for today, I would just want you to build 3 simulators. One is basically a temperature simulator. One is a switch simulator. So basically, which something shows on and off when it gets the signal. And an integrator, basically taking both of these and making them react together. Yeah? So 3 things. One is basically an actor, one is a sensor, and one is an integrator, which makes them work together. Yeah, because they all send to a server, you need these 3 components. I don't want you to send this directly to each other. I want one integration component, which then can combine the signals of lots of devices, because that is how we will work in the future. So co-op and MQTT. In MQTT, a little bit more work and simulators. Good. Thank you, and see you in the labs.